I guess first of all, thank everyone for joining us this evening. So tonight I'm going to talk about step functions and how you can use step functions to deliver customer values very quickly. In terms of the agenda, I'm going to start nice and easy and just talk about what is step functions and how it works. And I think one question I get quite a lot as well is just when do you actually use it? And also how does it factor into the equation of, when you build the microservices, all this talk around orchestration versus choreography, how does step functions factor into that equation? And then we're going to talk about some real world use cases that I've seen people sort of publicly talk about, how they're using step functions. And I'm going to wrap up with just some step functions design patterns that I've used and I've seen other people use as well. So starting off with just what is step functions, it's an orchestration service from AWS that allows you to model your business workflows as state machines. It manages the sort of state of your workflow, keeping track of where your execution is and giving you a scalable and resilient platform to build on top of, and allows you to focus on your business logic instead of infrastructure. So you're going to design your state machine using this JSON-based language, and I strongly recommend that you go through this official language spec. It's got a lot of information about what each of the properties mean, and also it's got some useful tips and examples that you can actually follow along as well. And if you design your workflow in the not Lambda console, the step functions console, you will also be able to just see what your workflow looks like. You can find the visualization. I mean, I typically find the visualization very useful, especially when you are collaborating with non-technical users, because they can actually follow along with what it is that you're building, rather than getting distracted by the sort of JSON syntax, and which is great because it's one of the things that I really like about building this business workflow is collaborating with business stakeholders, your product owners and whatnot. And one of the things that I still find that is missing is that you can't build your workflows visually using the diagram, but instead you have to start with JSON. The fact that you can't design your workflow using these visual tools is one of the feature gaps that step functions has with other services like durable functions from Azure or Node-RED from IBM. In terms of, so once you've defined your state machine, you can start an execution of that state machine with some input. So if you, in terms of, analogies, a state machine is kind of like a class in Java or in OO, and an execution is basically an instance of that class, and you have inputs which are arguments for your executions, which you can start with the AWS console, which under the hood just calls the step functions API to start an execution, which means you can also start it via the AWS SDK or the AWS CLI and so on. You can also start an execution with HTTP request with API gateway using the service proxy. And then you can also trigger execution using EventBridge or CloudWatch events, which lets you trigger executions with whenever you have some event rule that's being matched. Maybe you want to start an execution whenever an EC2 instance has been terminated, and or maybe you want to do that as a part of a cron job as well, which you can also configure in the EventBridge or CloudWatch events. So in most cases, most of your state is going to be using Lambda functions, and if you're using the serverless framework already, then you should check out this serverless step functions plugin. It allows you to also define your state machine in YAML inside the same serverless.yaml, and then when you deploy your state machine, they will be deployed together with the functions. And the plugin also makes sure that in terms of the permissions, is applying the best practices for in terms of applying the principles of least privilege. And then once you start an execution, you can also track its progress inside the step functions console using that visualization tool, so that when you have branching logics or retry logic, you can see the path a particular execution took, and the input and output for every single stage, every single step in your workflow. You can also inspect them as well inside the console, which allows you to really quickly identify any problems or any, bad input to your execution. In terms of the audit, it comes with some audit history out of the box, and it records up to 25,000 events in the history. So when an execution started and when it ends, and whenever a single step started, when it ends, all of that are recorded. And then when you're using Lambda function to execute a particular step in your workflow, you can also have this shortcut to the CloudWatch logs for that particular function. The annoying thing, however, here is that link only takes you to the log group for the function, and you still have to find the log stream that you want to go into, or you have to use filtering that in order to try to find the relevant logs for that particular instance of the Lambda invocation. So finally, in terms of just the terminologies, every time an execution moves on from one step to another is called a state transition. And the way that step function charges you is based on the number of state transitions that you have. And at 2.5 cents per 1,000 state transitions, it works out to be about $25 per million state transitions, which actually makes step functions one of the most expensive services you have on AWS, and is easily over an order of magnitude more expensive compared to the Lambda cost you're going to incur as part of your workflow as well, because you have to pay for step functions and you also have to pay for any Lambda functions that are executed as part of your workflow as well. So to address this particular cost issue or concern that people have, AWS released this thing called Express Workflows last year at around the reInvent, which is a much cheaper and also much more scalable variant of the normal state machines called and they call it Express Workflows. And the reason why it's called Express is because you can only run workflows for up to 5 minutes, whereas the normal state machines can run for up to a whole year. So Express Workflows are designed to support high throughput transactional systems. So you don't get that visualization tool anymore or the audit history in the console. Instead, all of your logs are shipped to CloudWatch logs instead. And in return, you can start something like 100,000 of these Express Workflows per second, whereas with the normal workflows, you can only start 2,000 of them per second, which again is highly relevant when it comes to those high throughput transactional systems. So in terms of companies that are using step functions in the wild, here's just a small handful of companies that I was able to find online. And later on, we're going to talk about some of the use cases that they actually have for step functions. And for those of you who don't know who I am, my name is Yan Cui. I'm a long-time AWS user. The last couple of years, I've been working with Lambda and serverless technologies on AWS pretty much exclusively. Did do some containers work, but let's not talk about that. So with serverless stuff, one of the first projects I did with serverless was to move this social network to run pretty much entirely on serverless. And nowadays, I'm spending half my time working with Lumigo as a developer advocate. And Lumigo is this troubleshooting platform for serverless applications. Think of it as something like all your CloudWatch and the X-Ray put together, but on steroids. The other half of my time I spend working as an independent consultant, where I help other companies move faster by adopting serverless the right way in terms of where to apply serverless technologies in their stack, and I guess coaching them on best practices and so on. And occasionally I help clients just deliver a product quickly. And in my spare time, I've got some books, I've got some video courses that I published myself as well as with Manning, and I also have a video course on the step functions as well, so feel free to check that out. And also running a bunch of workshops in person, but also online. We just announced our online workshop that's going to run for 4 weeks from May. So you're going to take about 4 to 5 hours per week over the course of 4 weeks, and to teach you everything you need to learn about building stuff for production with serverless technologies. So and if you stick until the end, I've got some discount codes for you, if you're interested. So let's talk about how do we build and design our state machines. With step functions, you have 8 different types of states. So for every single step of your workflow, there can be one of these 8 different types. The first and most common type is a task. This is where your state machine actually needs to do some work, typically by, say, invoking a Lambda function. And the task state itself is identified by the type attribute. And in this case, we're going to invoke a Lambda function, and we're going to pass in is ARN, or Amazon resource name, which is the unique identifier for a particular resource within your AWS environment. And the function will be called with the current execution state, which we're going to talk about in a minute. And then once it's done, it returns a value, or it fails or whatever. We either then catch the error, or in the successful case, we're going to transition to the next step in our workflow as specified by the next attribute here. And you can also optionally specify a timeout for this particular step. And the interesting thing here is that this is optional, and if you don't specify, then the default of 60 seconds will be used. However, one thing to keep in mind here is that step function doesn't actually know the timeout configuration for the Lambda function. So if the Lambda function itself can run for longer and you have a shorter timeout for the step, then you can potentially find yourself in a case where the workflow itself says it failed because it timed out, but the function is continuing to run in the background. Or vice versa, if the function timed out earlier, where you have a higher timeout, then step function is not able to capture that as a proper timed out exception, but it just see that as a general purpose error, so that if you got sort of more, I guess, specialized error case handling, where you want to do something different when it's timeout, then you need to be quite careful in terms of how you configure this timeout, probably to be just maybe slightly less than the actual timeout for your Lambda function. All right, there you go. You should match the timeout configuration for your function. Another thing worth mentioning is that a task state doesn't have to just invoke a Lambda function. You can use it to integrate with other AWS services directly, including you can trigger an ECS task, which can run on Fargate if you don't want to manage ECS cluster yourself. You can also read and write data to and from DynamoDB tables, publish messages to SNS topics or SQS queues, or you can even trigger a task in AWS Glue for some ETL job, or trigger some SageMaker machine learning thing that you're doing as well, without having to write custom Lambda code to glue things together. So I mentioned earlier that when you start an execution of your state machine, you're gonna give it some input. So that input is then bound to this dollar symbol, and it's passed into your first step in the workflow as the input, and we can reference different attributes of that input using this particular syntax, like a $.x, to access the value of the X attribute on the input. And in this case, I've got a conditional branching logic here, and the condition basically translates to if X is greater or equal to 42 and Y is less than 42. And then when it's matched, then it's going to transition to the subtract state based on our current input of X 42 and Y 13. And in this case, imagine the subtract state is a task, is therefore triggering a Lambda function. So the Lambda function is going to get this whole input as it currently states, as it currently stands, with X42 and Y13, that we can actually access them as the input or the invocation event objects for our Lambda function, just like this. And then whatever our function returns, we can actually bind the return value. Normally, the return value would bound to the whole input. You will override the whole input, the dollar sign symbol. What we could do in this case, if we don't want to override the entire input, so overriding X and Y, what we can do is to say, please take the output from this state and put it into another attribute. In this case, let's put into an attribute called N, so that when our function finishes and the state comes back, it's going to take the output from the function and put it into an attribute called N on our input, which the whole thing is then passed as the input to the next step. And in this case, if we say, okay, I don't want to take the entire input because a lot of it is not relevant to this particular step of my workflow, you can also use the input path to say, only take one part of this input and pass into the state, so that now that the input for this double function is expected to be just an integer. So it's going to be coming from the N attribute from the current input $, and whatever we return in this case, because we're not specifying the output, the result path, is going to become the it's going to override the value of $. So that, and since this is the last state in our state machine, this output is going to become the output for the whole execution. So when you look at the output for the whole execution and the input, you're going to see input being x42, y13, and the output being 58. Another way you can sort of manipulate and modify the input state, the execution state, or the dollar symbol along the workflow is use what is called a pass state. So like the no-op state I've got here, which all it's doing is modifying the current execution state by adding an attribute called the answer to the question of life, the universe, and everything, which someone already said the answer earlier, which is 42. And then you can then, when it's executed, if the current input is just an empty object, then by running this pass state, you're going to then add another attribute to our input, our current execution state, so that it gets then propagated onto the next step in the workflow. So where this becomes quite useful is, for example, if you don't control the input, maybe it's coming from another microservice or coming from an external client, and you need to slap a few extra attributes onto the input before you process them, like adding a timestamp or some static value. And this is going to save you from having to write some custom Lambda code just to do that particular thing. And then that's the wait state. And it sounds a bit silly, but one of the most powerful things that step function lets you do is to just wait, which is rather inefficient to implement with Lambda, because essentially you will have to have a function that just keep on running and doing nothing, and you're paying for idle. And you're then also subject to the maximum execution time Lambda has for 15 minutes. And with step functions, an execution can run for up to a whole year. And so you can have a wait state that just waits for a very long time without having to pay for the idle time. And we're going to see how Coca-Cola uses this as the most cost-efficient way to build like a state machine that just waits for like 90 seconds. You can also wait for a specific number of seconds or until a specific timestamp in UTC, but that's a fairly static behavior. More often than not, what we see is people control how long a step should wait for by modifying, by passing it, by adding something to their execution state. And then they'll use a seconds path or timestamp path to say to dynamically control how long the wait state should wait for. And then so for example, you may decide to do something where you start a cron job and then you poll and see if the job complete yet, and you want to add some kind of exponential backoff so that you can then use this timestamp path and the seconds path to control how much time to wait between every time you poll. So maybe you start with 1 second and then 2 seconds, 4, 8, and then eventually you only check once every minute if a job is not completed within the first couple of minutes. And then you have the choice state, which allows you to add the branching logic to your state machine. You can specify the branching conditions in this choices array, and each of these conditions would specify a next state, so that when it's matched, you tell the state machine what state to transition to. And in this case, if the input contains a name attribute and is equals to nil, then our execution flow would move to the red pill state. And then you can also specify a default, so that if none of the choices match, then this is our default branch to go to the blue pill state. You can also compose different conditions together using and or and multiple different ways to combine and nest them that way as well. And we also have the parallel state, which allows you to specify different sort of branches of execution that's going to be executed in parallel. And the state would complete if all the parallel branches have completed, or if one of them has failed. If any of them failed, then the whole parallel state would be considered as having failed, so that if you got any try catch block around this state, then you fall down to the error or catch block. So the parallel state is, I guess one of the problems of the parallel state is that it's so static. You can't say, okay, given that I've got an array of 5 items, I want to start 5 concurrent 5 parallel branches, and when I've got 10 items, I want to start 10 parallel branches. No, so this is for executing a specified static number of parallel branches concurrently. So to do that dynamic parallelism, AWS announced a map state last year around reInvent time again, which allows you to do just that, whereby you can take an array as an input and you can dynamically create parallel executions that process individual items in parallel, and you can control the concurrency with an optional max concurrency attribute, whereas by default step functions would try and execute the iterations with as much of concurrency as possible. Some of the states like task, pass, wait, and parallel, they let you terminate execution when they're complete by saying end to be true, but not the choice state, in which case you might have to have some state just represents that is a successful termination for the whole execution, and that's why you have the succeed state, and you also have the fail state as well, where you can specify the error type and the error course. And you can also go a bit further than that. You can also nest workflows together, where you can then build larger and more complex workflows out of smaller and simpler ones. And some of the real-world examples we're going to see later could have benefited with from this, because some of the examples I've seen in the real world are just so big, they don't even fit onto a screen anymore. So in that case, I'm just going to continue and talk about when we should use step functions. So given that it's one of the most expensive services on AWS and significantly more expensive than the Lambda invocations that you're going to incur as part of your workflow as well. And also is whenever you use step functions, it's just another thing to add to your stack, another service that you have to learn and use. What do you get back in return exactly, right? I mean, the cost was by far the biggest reason why you wouldn't use step functions for some of the workloads, even though nowadays that kind of have changed a little bit with Express workflows, with a much cheaper variant of the standard workflows. So that can answer that question. But in terms of the normal standard workflows, on the pro side of things, the visualization tool is very useful. As I mentioned earlier, it's great for you to be able to design workflows and collaborate with stakeholders that don't really understand code and have no idea what all this blob of JSON means. That's where I think I really like to have if AWS would decide to let you design your workflows using those visual tools, as opposed to you have to start with JSON. And the visualization tools can also let you, I guess, debug problems very easily, so that you, like I said, you can collaborate with team members that are not engineers. But in terms of just debugging, I also find it quite useful for, say, QA engineers or even customer support team to say, okay, a customer complained about a payment not being processed. They go to the order ID, look up the workflow, and they see, oh, okay, right, it failed because we couldn't get back an answer from PayPal within the time window that we had, which was, I don't know, 30 seconds or whatever. So make it very easy for non-technical members of the team to debug issues and then handle them without having to look into the code and dig around different logs and trying to find the right information to figure out what actually happened. Using the visualization tool becomes very easy for you to identify problems, and there's another aspect in terms of the error handling and debugging is so step function gives you a lot of control around how you do error handling and retries, because you don't have to worry about your function timing out while you're retrying, and you can have a lot more flexibilities once you remove that time constraint. So the problem here is that it makes it a lot easier for you to work out what timeout to use for your Lambda function. So when you look at the Lambda best practices guide from AWS, it recommends that you keep your Lambda function timeouts to be very short, maybe a couple of seconds, and that's great for the positive path. But it becomes difficult to do when you have to consider, you have to factor in retries and exponential backoff for every single thing that you are talking to as part of your one execution. So for the DynamoDB, for example, the built-in retries for AWS DK in the node has got, I think, up to 10 or different retries, and the last one, because you're using exponential backoff, the last retry, I mean, overall the whole thing would take 59 seconds for all 10 retries. So when you have the constantly factor in, okay, right, for the error handling and the retry and the exponential backoff, what is the worst case timeout I need for my function, then that can push it out way out beyond what you should be using for most functions. So if you take your error handling and retry logic out of the function into your execution flow into the state machine, then you remove some of that constraint that you have to think about every time you try to decide what is a reasonable timeout for your function for both the happy path as well for the failure path. And also surfacing those error handling logic into the state machine also makes it easier for somebody else to understand what the application is doing in terms of, okay, something went wrong, and we waited and for a second and then we tried again, without having to dig into the code and understand what the code is doing, which is again just massively helpful for customer support teams or people that are not engineers to figure out what the actual problem was. And then you also get this full history of what happened during an execution, and the history is retained for up to 90 days. So again, great from the audit point of view. So if you look into the step functions console, first you see all the different executions that has happened in the last 90 days. You can filter by the state so that you can easily find executions that failed. And then inside your step functions console, you can see the input and output, the actual execution path, and then you can click on individual steps to see what the input and output and the exception if the step actually failed for whatever reason. And then you get a full history of every single state transition that happened. When did it start? When did it finish? What was the input and what was the output? So this is relevant for task states that invokes lambda functions, where you can also see the exception, the error message, as well as the stack trace when your function or the task state errors because the lambda function errored as well. So those are some of the high-level pros and cons to keep in mind when you're thinking about using step functions. I typically reserve the use of normal step functions state machines for 3 scenarios where either I'm building a business-critical workflow, things that usually makes the business money, like taking payments or signing up new users. So in which case, the actual premium that I'm paying is totally worth for the more robust error handling and auditing I get back in return. And then also I use it for complex workflows that involves a lot of different branching logics and so on, so that rather than having to go through the code to have to figure out what the application is doing, and also making sure that I have really good, trace logs all the way through, having step functions giving you that visualization makes it a lot easier to debug these complex workflows where you can have lots of different branching as part of the workflow as well. And again, it becomes a very powerful both design as well as diagnostic tool for working with business stakeholders as well. And also, if you've got some long-running workflow that needs to run for much longer than 15 minutes, say you have to wait for a very long time, that's also a really good use case as well, especially when you consider that a Lambda function can only run for up to 15 minutes. And even though you could write recursive functions, it's not something that AWS would actually recommend you to do. So using step functions kind of give you a way to take that recursion out of the function code and into the state machine itself, where you can also enforce this workflow level timeout just in case you find yourself stuck into an infinite loop. And then there's express workflows, and like I mentioned earlier, it's designed for those high throughput scenarios where you can still design your workflow with the same JSON-based language, but there's some important differences to keep in mind here. The first one, there's this link here, which is very, very useful when you want to figure out the difference between standard versus express workflows. One of the big ones is just how long an express workflow can run for, which is only 5 minutes. Whereas a standard workflow can run for an entire year. And then there's also big difference in terms of the throughput. With standard workflows, you can only start 2,000 executions per second, whereas with express workflows, again, designed for high throughput scenarios, you can start at 100,000 executions per second, and there's no limits to how many state transitions you can have per second. And again, on the standard side of things, you have a limit of 4,000 state transitions per region. In terms of pricing, they also behave quite differently. With standard standard workflows, you charge based on the number of state transitions. With express workflows, you are charged very similar to how Lambda charges you based on the number of requests you make to start executions, but also based on the amount of time your executions run for and how much memory they consume. And when you look at the actual costs themselves, they're actually very comparable to the equivalent Lambda costs, which in this case would work out considerably cheaper compared to standard workflows. However, since you're likely to implement most of the states in your workflow with Lambda functions, you will also still incur the cost for both Lambda and Lambda invocations as well as step functions. So just bear that in mind when you're trying to work out the total cost for your step functions and workflows, whether it's standard or whether it's express. The bottom line here is that you should use express workflows for those high throughput and short-lived workflow scenarios where you have much cheaper costs, but you also lose some of the visualization. And I mentioned earlier that with express workflows being designed to operate at such a high sort of scale, you also have the option to only log error messages or exclude the execution data altogether, or even turn off logging, just to avoid generating a massive amount of logs, which can then cause your cost to go up for CloudWatch logs. If you're writing a lot of data, a lot of your logs to CloudWatch logs, that cost can go up really quickly. CloudWatch logs is another service that can work out to be a lot more expensive than Lambda functions themselves. And then there's also the sort of related question of orchestration versus choreography. When you're building microservices, which one do you use? And step functions definitely falls on the orchestration side of things, where you've got this state machine pulling the strings and controlling the entire flow for the execution. So my rule of thumb is to use orchestration within a bounded context of a microservice, but use a choreography between different bounded contexts. So and that's because within a bounded context, I've got a fairly focused purpose or responsibilities, and hopefully I only have a small number of different components that I have to think about, so I can keep all of them in my head at the same time when I try to understand what this microservice is doing. And since everything have to work together to achieve some business capabilities like processing payments, so that they form this highly cohesive unit and I own everything within this bounded context, so I'm free to make changes and reorganize things so long I don't break my contract with other services or any sort of external facing part of my bounded context. And I've seen quite a lot of people use choreography inside their bounded context and to implement some kind of workflow using messages like queues, SNS topics, and so on. And I generally think they are a bad idea when you do that inside a bounded context. I mean, I love building systems using events so that you can really quickly and easily integrate different services together. But I think it's a bad idea when it's done inside your bounded context for microservice, because the workflow itself doesn't actually exist as a standalone concept anywhere except inside your head, because all you can see from your architecture point of view is just a bunch of loosely connected functions that are stringed together via some shared SQS queue or SNS topic or event bridge, event bus, which make them very difficult to reason about and debug when you can't even see what is the workflow, what are the different sort of branching conditions happening, and you have to kind of just build that understanding up in your head by looking at the code and looking at the messages that's flowing around. And so any kind of end-to-end reporting is also very difficult. Even something simple like having a timeout to the whole payment process, it becomes really difficult to implement when all you have are small loosely component functions that sit between different queues and buses and whatnot. And if this is what you have today, and those are the sort of problems that you're experiencing, then do consider moving your workflows to step functions instead. However, When it comes to, I guess, communication between different microservices and bounded contexts, I would definitely go down the route of publishing and subscribing to events through some kind of event bus. Could be EventBridge, could be SNS topics, Kinesis streams, or whatever, so that different parts of the larger system can stay loosely coupled and they can build on each other's events and evolve and fail independently. And you don't have that one component that have to know every single service and then have to have that, that God mode where you can orchestrate everything. And talking about EventBridge and SNS, I also wrote a post on why you should consider using EventBridge instead of SNS for greenfield projects nowadays. And finally, so orchestration and choreography doesn't have to be mutually exclusive. For example, inside my state machine, wherever I'm introducing some kind of a state change, like changing the status of a payment or an order from pending to process, for example, I will still publish those as events to my event bus, and so that other systems can listen and react to those events and build their feature on top of those events. For example, when a payment is completed, maybe you want to send an email to a customer, or maybe when an order has completed and it's the first order for this customer, we want to send out some promotion, and we don't want to build that into the sort of order processing system. But then, so long we're still publishing those events from our workflows, we can still build other microservices on top of those events without making them really tightly coupled together. Again, just my rule of thumb to prefer orchestration within a bounded context, but choreography between bounded contexts. So let's take a look at some real-world use cases for step functions. I mentioned Coca-Cola earlier. They run a state machine execution every single time you use their vending machine, because the problem that they were facing with was that some of the back-end systems they were dealing with was slow and has, I guess, just race conditions, some timing issue. And so what they decided to do was to add a 90-second delay before they try to process your payment, and they found that step functions was the most cost-efficient way and most scalable way to implement this wait. So I thought that was quite a funny use case. They got this massively scalable workflow orchestration engine, and all you use is to wait 90 seconds, which is kind of funny. And then they also use step functions to update the nutritional information on the labels for over 100 different brands they've got in order to comply with the FDA regulations. And they managed to move these to step functions and reduce their processing time from 36 hours to all the way down to 10 seconds, which is a pretty big improvement. And then there's also Thomson Reuters, which uses step functions to transcode videos, where they will split the original video into multiple segments and then encode them in parallel. And finally, they will stitch the encoded segments together. And moving to step functions helps them reduce their average processing time from 20 minutes down to 2 minutes, which is again is a tenfold improvement here. You got the Foodpanda, which is a food delivery service. They also use step functions to manage their whole food delivery experience, from finding available drivers to running their assignment algorithm and dispatching the driver and telling the customers when the food has been delivered and so on. And then The Guardian, which is a big newspaper in the UK, they manage the subscription fulfillment with step functions, and similar with Yelp, they use it to implement their bidding system. And my last employer, DAZN, which I hope many of you know about, being a big sports streaming platform and available in Germany. We also use step functions very heavily in the payments team, where we did a lot of our payment processing and the subscription systems with step functions. And I can tell you from experience that this is a drastically simplified version of the actual payment processing workflow that we had in production. The real thing was much more complicated. And so coming up to the end of the talk, I'm just going to wrap up with a few design patterns. One of the more better known ones is the Saga pattern, which is useful for managing failures in a distributed transaction, and which is quite a common challenge that we see in microservices, where we often have to call multiple APIs in order to complete a single user transaction, like booking a holiday, which none of us are doing right now, unfortunately. When we do is need to book holidays again. You can imagine we have to book hotels, flight, and car rental in a single transaction. And if, of course, all of these are different third-party systems that we have to call. And if one of them fails, maybe we want to roll back the booking for the flight and the hotel as well. So if you model that as a workflow, you've got your actions for booking hotels, flight, and car rental. And if it's all complete, then we're gonna be, happy days. You're gonna complete successfully. But then if we do need to roll back, you need to roll back in the reverse order to then cancel anything that apply the equal and opposite action to cancel the hotel, flight, and the car rental. So in the successful path, that's the way it looks like. But in the failure path, we need to roll back any changes that we've done so far for the, say, booking a hotel, whatever changes we made so far already, we need to roll those back. And if we failed a bit further along where we've booked the hotel, but when we came to booking the flight, it failed, then we also then need to clean up the hotel booking as well. So you would roll back in the reverse order. And if you look at the book flight state, for example, the next state points to book rental if it's successful. But if it fails, then it's going to go to the cancel flight state instead, where we're going to clean up any data changes that we made so far. And then we're going to maybe record some detail about a failure, maybe send a notification to some human operator as well. And then we're going to also then on the next attribute for this cancel flight, we're going to then also cancel the hotel. In this case, we're going to clean up the data for the hotel booking. We're going to call the hotel API system to please cancel the hotel booking and all of that. And here we've got a self recursion, and this is because when we have a catch around the whole cancel flight state. If it fails for whatever reason, we want to just keep retrying until either it times out or we exceed the maximum number of retries. So in this case, I've got infinite recursion here to keep on checking if it fails. But in practice, you probably have a number of attempts. So you use a try to say retry this for say 10 times, and if it still fails, then go to some state where it sends out some notification to a human operator to actually go and do something about it. The code for this particular example is available on GitHub, so feel free to go and play around with it yourself. And with step functions, you can also implement callbacks where you can wait for some external signal, maybe someone clicking on a button on your on some CMS or on a link on an email, for example, for some process to go through. It could be a case of, okay, I want to deploy to production, and we have a pipeline that involves someone saying okay on a screen somewhere, or I guess maybe you want to do something and you require some approval, and that sends out email to somebody, and the administrator have to click an OK button in the link in the email. So that can all be done using callback. And this is something you can do via this token. So walking through example, we have a state machine. We're gonna publish a message to SQS. So now we're gonna tell step functions to generate a task token at this point, to include in the message payload to SQS, and then to just wait. It puts the execution to sleep, and you just wait until someone picks up the message and that they've processed it, doing whatever it is they need to do. We don't really care. All we care about is that when they're done, they tell us what happened by calling the send task success or send task failure method against the step functions API with the task token we gave them, along with the actual response, the payload for success or the error for the failure case, which allows step function to then record the outcome for the task and then move our execution along to the next state. And this is what it looks like in the state machine's definition, where just for integration with SQS, you have a very special ARN, which tells the functions that to please call SQS.sendMessage, and with the suffix of .wait for task token, it tells step function to then generate a task token, and that it should wait, and it should stop the execution and wait for the outcome from the task token. And to get that task token itself and put it into the message into SQS, we can use the $$ notation to access the current execution context, which contains a bunch of other information like the state or the execution ID, input, start time, the ID for the state machine, etc., as well as the task token that we're looking for here. The downside for this approach is that whoever that's processing our messages, they need to have access to step functions in our environment, which is fine when it's something that's running in our AWS account. But for third-party APIs systems or something else running in a different account, it would be much nicer to have an HTTP endpoint that they can call and post a response with the task token instead, which would then in turn call our step functions on their behalf using the task token, so that the third party doesn't need to have any permissions to our environment. So again, this is very useful for the cases where you're sending emails and someone wants to click a link and that should just hit some HTTP endpoint. And if that's your use case, then check out this application from a Serverless Application Repository. In the Serverless Application Repository from Ben Cahill, which basically wraps this HTTP API for you so they can deploy it as a single SAR application into your AWS account. The same approach works with other services as well. For example, you can use it to invoke a Lambda function and give it the task token. You can send an email out, include it in the URLs for the email you send through SES, for example, which then triggers, makes a callback via the HTTP endpoint that we talked about. And the last pattern I want to talk about is MapReduce, where you can make use of the dynamic parallelism you get from the map state to trigger lots of concurrent workers to process items in an array, and they're all going to spit out some output, which the nice thing about the map state is that it collects and all these results for us and put everything into an ordered array so that positionally all the output match up with the input array as well, so that you don't have some other process you need to have you need to run to keep track of the output for all the different tasks that you have started. And then once you have everything, then you can then have another step in your workflow to run some reducer logic over the output, which really simplifies this type of MapReduce like systems. One thing to keep in mind though is that there's a limit on the input size, the current state, the $, which is only 32 kilobytes, and that's not a lot. So when you're dealing with very large payloads, then you want to store them in S3 first, and then just include the S3, I guess, bucket and object key, or maybe just S3 path as output, so that gets collected and passed along to the reducer, and the reducer would then read the data from S3 instead if you're dealing with very large payloads that can't fit into the input state. So that's it. That's everything I've got for today. As I mentioned earlier, I work mostly as an independent consultant, so I would love to have a chat and see how we might be to work together and how I can help you guys accelerate the product and feature development using serverless. And if you want to skill up yourself or your team, I also run a bunch of workshops that covers everything you need to know to build production-ready serverless applications, which unfortunately all the in-person workshops has been pushed back to later in the year when hopefully all of us are out of lockdown. But I do have a virtual workshop running online from May 4th to May 29th as well. So check it out. Go to theburningmonk.com/workshops to see all the different workshops I'm running. And you can also use this code to get $100 off, €100 off my workshops as well. And the same code also can be used to get 20% off my video courses. And with that, thank you guys very much for your time and attention for this evening. And I guess if you've got time, I'm happy to take any questions you guys have.